Hello everyone. So today we will start our chapter 4, that's software process models. So in our previous chapter we have discussed about software lifecycle and we have discussed about different phases in software lifecycle. That's requirement engineering, design and specification, implementation, testing and maintenance. So in this chapter, we are going to learn about how do you put these different pieces together to create a workflow or a process that a team can use to build their software. So software process model. So if I just talk about software process first, so software process is a set of related activities that leads to the production of the software. So these activities may involve the development of the software from scratch, or it could also involve modifying an existing system. So software process is actually regarding those activities in your software development. And a software process model is a simplified representation of a software process. So each model represents a process from a specific perspective. So here you understand that the main activities in our software development is actually same in every model. The model just simply affects the flow among activities. So that's our software process model. And the goal of this software process model is standardization to achieve predictability, productivity, higher product quality. And also if you know about or your activities know about the flows, you can plan better, right? And you can also plan on time and budget requirements. So now before jumping to conventional models, we will talk about an earliest approach, that is code and fix. So code and fix, it also sometimes called cowboy coding. This is the earliest approach and it is considered the simplest software development process. It is a cyclic process, consists of two major steps, coding and fixing. So in this model there is usually no extensive planning or no well-defined design steps. So what happens that after some initial discussions, teams just start the coding process and fixing usually happens along the way, so the team can fix the major bugs on the way to continue the process. So the process we usually do in our semester, the projects that we do in our semester, that's actually code and fix, right? We don't give enough time or we don't put enough effort in our requirement engineering phase or design phase. We simply discuss an idea with our friends or teammates and then we start coding. So that's a code and fix. But what's it's really convenient for a small project, right? But it's not actually convenient for big, not even mid-level project. It's not convenient for mid-budget projects. So it's convenient for a small project, and also when you know that you don't need any initial planning in that, or also you know that the project won't require any further development. At that time you can use code and fix. But at the earliest stage we had only this model, code and fix, and it involves actually a huge risk of failing to achieve customer satisfaction since there is no concrete understanding of product requirement. So the product is either rejected or have to be redeveloped. So after the failure of code and fix model, it was realized that a more detailed and careful analysis of the requirement was necessary before design and coding could start. So after the failure of code and fix model, it was realized that we need models for describing the process in a precise way. So here comes the models. So now there are lots of models out there. Of course, you can even create your own model. But the question is, why do you need so many models? Couldn't you just have one model and then everybody follows it? Well, every team, every project, every organization is different, right? And the constraints that are on any project are different. So one model may fit in a particular project, whereas one same model may not fit for another particular project. So that's why it's important to learn about different models so that when you are in a situation to find or to select a model for your project, you can choose the right one. So after they find out the problem with code and fix model, so at that time they realize the importance of model, and then Bohem states what should be the goal of the process model. So here the two important thing is order of stages. We have already discussed that the model will just define the flow of the activities, and also the transition criteria, that means when should we move next. So the two important question is what shall we do next, and how long shall we continue to do it. That what actually process model defines. So now I want to talk about two models, that is black box model and white box model. So black box model is actually, here you can see at first you have some informal requirements, and then you will start doing your process, and then you will do all the activities that have to be done, and then you will get the final output. So there is no customer interaction, there is no review or feedback process. So that's why this is a black box model. But the problem with this model is the assumption that the requirements can be fully understood prior to development. But unfortunately, these assumptions never hold. So in white box process, we actually change the project based on the feedback from the customer. So the benefit here is it reduces risk by improving visibility. In every stage, we are contacting with the customer, and if they are giving any positive or negative feedback, we are working with that feedback. So the visibility is clear also, and there is less amount of risk, right?